Okay, this one is about a pipe manifold, and there's an image here, and it has water, it gives you a temperature, and it asks for the velocity in the largest pipe. So let's go ahead and take a look at that. What is the largest pipe? Oh, it's number 7. Okay. And what we see here is it's a manifold. We have 2 incoming streams and 1 exiting stream, and you're given the diameter of each of the incoming, the velocity of each of the incoming, and then the diameter of the exiting, and your task is to find the velocity. So in steady state flow, what you say to yourself is, okay, I know I have these coming in and then combining and exiting here, and essentially I know that the sum of the sum of the areas times the velocities for the incoming streams is going to be the sum in steady state of the areas of the velocities of the outgoing streams. And you can see that since these are theoretically cylindrical pipes, that the area is going to be equal to pi. The areas for each of these will be equal to pi over 4 times the diameter squared. And you can see that since those, I'm just going to take a bit of a shortcut here, that since those area terms are on this side and over here, the pi over 4 is really going to drop out of the equation. So we're going to be left with the diameter squared times the velocity of each one, and summing those up. So let's go ahead and plug and chug. But before I do it, I'm going to look at this. Let me just look at the sum of the area here, or the sum of the diameter squared. This is going to be 20 squared, that's 400. 400, 10 squared is 100, so 500 squared times the same velocity, 5, is going to equal 30 squared. That's 900 times V3. So let me just I'm sketching this out in my mind before I run the numbers. So I have basically 500 times 5 meters per second equals 900 times V3. So, oh, I'm solving this already. I didn't mean to. V3 equals 500 over 900 times 5, which gives me, blocking those out, 5/9 of 5, 25 over 9, something like, I don't know, V3 is 25 over 9 is about 2, it's almost 3, so 2.7 maybe. 2.7, my units are meters per second, so the velocity, I'll write it over here, velocity is equal to 2.7 meters per second. I'm doing that in my head. I should probably use a calculator. Using a calculator, V3 is 2.8 meters per second. Does that make sense? Is it less? Larger diameter, so I'm expecting it to be less than this incoming velocity. It looks good.